Okay, I found a worksheet, and so we're going to do some practice now. We have strontium and oxygen, and we are going to put those together. The question asks what's being oxidized and what's being reduced. So if we start with what's being oxidized, strontium is a 0, oxygen is a 0 because they're elements. Strontium is an alkaline earth metal, so he's always got a +2 charge. Oxygen's a -2. So who is being oxidized? The one the charge is going up. Strontium is becoming strontium with a 2+ charge. Reduced, oxygen is going from a 0 to a -2. So strontium is losing 2 electrons, and oxygen is gaining 2 electrons. Okay? Now, let's do the next one. We have lithium and sulfur. Lithium, 0 charge. Sulfur, 0 charge. Lithium +1, sulfur -2. So, lithium is being oxidized. He's going from a 0 to a plus lithium. Lithium +1. And he's going to be losing 1 electron. Being reduced, sulfur is going from a 0 to a -2. So he is gaining 2 electrons. All right, now if we want to put these together, and balance it, we only have 1 electron being formed by the lithium, but sulfur is going to need 2. So we have to go through and we have to multiply this whole reaction by 2. Okay? If we combine these into a balanced equation, we get 2 lithiums plus 1 sulfur plus 2 electrons. So I've just brought the lithium down there, the sulfur here, the electrons there. On my other side, I have, once again, 2 times 1 is 2 lithiums plus 1 sulfur plus 2 electrons. In math, when we have like terms, we can combine those. In this case, they would cancel out. So the balanced equation is 2 lithiums plus a sulfur gives us 2 lithium ions plus 1 sulfur ion. Now, my suggestion is, as we do this next one, is that you go ahead and hit pause and try it on your own and then check your work. What's being oxidized? Cesium's a 0, bromine's a 0. Cesium's becoming a +1, bromine's becoming a -1. So the cesium is being oxidized. And he's losing 1 electron. The reduction is the bromine. I need to pick up the pen a little bit better on this slate. And bromine's gaining 1 electron. They work out just fine. Okay, try it again. Hit pause after I reveal our equation. Who's being oxidized? Magnesium is going from a 0 charge to a +2. And nitrogen is going from a 0 charge to a -3. So he's being reduced. Magnesium is losing 2 electrons, and nitrogen is gaining 3 electrons. If we want to balance this, we're going to have to put them together. 2 electrons, 3 electrons. And we need to multiply both by the magnesiums by 3 and the nitrogens by 2. That would give us 3 magnesiums plus 2 nitrogens plus 6 electrons produces 3 magnesiums plus 2 nitrogens plus 6 electrons. Electrons cancel out, and there you go. All right, the rest of these are very repetitive. I'm going to go ahead and move along to another section. Hopefully you've got this. If not, here, I'll go ahead and let you pause. You can pause for a minute and practice, and then we can get it checked. Actually, let's go ahead and do number 10 before we move on. Sodium has a 0, so he's being oxidized to become a +1. Hydrogen is being reduced from a +1 to a 0. Sodium is going to lose 1 electron, and hydrogen is going to gain 1 electron. Okay, really, that wasn't that big of a deal. The oxygens aren't involved. That's why I wanted to throw that one in there. Okay. Let us do oxidation numbers. Practice figuring those out. A says sulfate. Sulfate, of course, SO4 with a -2 charge. You can find that on the back of your periodic table. Each oxygen is a -2 for a total of -8. Because it's a polyatomic ion, it has to add up to its charge, which is a -2. So the question is, what minus 8 will give you a -2? And the answer, of course, is 6. Next one, tin, by himself, an element, he's a 0. Next one, sulfide. He's a sulfide because he is an ion, and his ionic charge is given. He's a -2. Iron here, we know it's given as a +3. Tin +4. Nitrate. Once again, polyatomic. You can get it from the back of the periodic table. Going to add up to -1. That looks like a 7. So our oxygen's always -2, -6. X minus 6 gives you -1. We know that that is a +5. Ammonium. One more of our ever-friendly polyatomics. The only positive one that we have learned. Okay? So this time, instead of equaling a negative charge, because his charge is a +1, he's going to equal a +1. Hydrogen's always a +1 unless it's with a metal. Nitrogen's a non-metal. So we have a total of 4 charges there. So what must nitrogen be? X plus 4 is equal to a +1. Nitrogen's got to be a -3. Okay. Let us the oxidation numbers of chromium. Feel free to speed ahead if you don't want to watch this. Cr2O3. Oxygen is a +2. 2, I mean not a plus 2, a minus 2 for a minus 6. So chromium has to add up to 6. There's 2 chromiums, each has to be a plus 3. Sodium dichromate. Each oxygen is a negative 2 for a negative 14. Sodium's always a plus 1, and there's 2 of them. 2 plus what? Minus 14 equals 0. 12, there's 2 chromiums, each one's a plus 6. Chromium sulfate. Okay, what kind of chromium is that? Thinking of naming. We know sulfate itself has a negative 2 charge, and it's bonded 1-to-1 with the chromium, so the chromium has got to be a plus 2. Oxygen's always a negative 2. 2 times 4 is negative 8, so sulfur here has to be a plus 6. Chromate is CrO4 with a negative 1. So we're going to add up to negative 1. Negative 2. 2 times 4 is negative 8. So chromium has to be a plus 7. Dichromate, Cr2O7. You know what I did? I just did that wrong. Chromate is a negative 2 charge, so he's a plus 6. So all of you that figured that out, and we're going, wait. Good job. Dichromate is a negative 2. So we have a negative 14. X minus 14, that's equal to negative 2, would be 12. There's 2 of them. Each one is a plus 6. Okay. Now, use changes in oxidation numbers to determine what is being oxidized and reduced. Okay, we're not going to worry about balancing, it says. We can, though, and I might go ahead and do that just for good practice. Okay, carbon's by himself, he's a 0. Hydrogen's a plus 1, oxygen's a negative 2. Sulfur here's got to be a plus 6. 6 plus 2 is 8 minus 8. Okay, oxygen's negative 2 for a total negative 4, so carbon has to be a plus 4. Negative 2, so we have a total of negative 4. Sulfur has to be a plus 4. Plus 1 minus 2. What's being oxidized? Our carbon went from a 0 to a plus 4. So if we write out our equation, carbon is going from a 0 to a plus 4, which means he's losing 4 electrons. Who's being reduced? Sulfur is going from a plus 6 to a plus 4. So he's gaining 2 electrons. Okay, there's 4 available though. That means there will be 2 sulfurs who will react for every 1 carbon. So our overall will have carbon plus 2 sulfurs plus 4 electrons, which are going to cancel, gives us a carbon with a plus 4 plus 2 sulfur plus 4s. Now, on the test, it asks you what species is being oxidized. Well, we said that carbon was being oxidized. The carbon atom is found as an element. So your answer, the species that is being oxidized is carbon. Sulfur is what's being reduced, so the species where sulfur is found is in the sulfate. All right, next one. Who is being oxidized? Hydrogen's plus 1, plus 1, plus 1. Hydrogen's not. Nitrogen is a plus 5 here. minus 6, plus 1, plus 5. Oxygen, of course, is a minus 2. He's a minus 2 over here. Hydrogen, we already said, is plus 1. Iodine here is a minus 1, and now he's a 0. Nitrogen here is a minus 2, or oxygen is a minus 2, so that nitrogen must be a plus 2, plus 1 minus 2. Okay? What's being oxidized? Whose charge went up? That would be our friend iodine. Iodine is going from a negative 1 to a 0. How many electrons did he lose? He lost 1 electron. Nitrogen is going from a plus 5 to a plus 2. So he is gaining 3 electrons. If we put these together, we need to multiply all these by 3. We get 3 iodine plus N5 gives us 3 iodine 0 plus N2. Okay? Yeah. Okay. Potassium's a plus 1. Oxygen's a minus 2, minus a total of 8, plus 1. Manganese has to be a plus 7. Hydrogen's a plus 1, chlorine's a minus 1. Chlorine's a minus 1, there's a total of negative 2, so this manganese is a plus 2. This chlorine is a 0. Hydrogen's a plus 1, oxygen's a minus 2, potassium's a plus 1, chlorine's a minus 1. So, who is being oxidized? Potassium doesn't change. Manganese is going from a 7 to a 2, but that's the charge is going down, so that is not oxidation. Oxygen stays the same. Hydrogen is the same. Our chlorine is, in fact, our oxidized friend. The species the chlorine is in is hydrochloric acid. We're going to make a chlorine that's neutral. Each chlorine is going to lose 1 electron. Okay? Who's being reduced? Well, we just said manganese was going from a plus 7 to a plus 2. How many electrons is he gaining? Holy cow, he is gaining 5. If he's gaining 5, we have to have 5 reactions here. Putting that together, 5 chlorines plus 1 manganese, 5 chlorine as part of an element. There you go. Okay? All right. Oxidizing and reducing agent, we're not going to worry about. Half reactions. Let me get my little box here. I wonder if I can move him like this. Yeah, look at that. So clever. Half reactions. Plus 2. Manganese in this case is going to be, that'll be a negative 8. It has to add up to negative 1, so he's a plus 7. Iron's a plus 3. Manganese is a plus 2 there. So, who is being oxidized? Iron is going from a plus 2 to a plus 3. So he is losing 1 electron. Manganese is going from a plus 7 to a plus 2. So he is gaining 5 electrons. If I want to balance this, I will need how many of the oxidized reactions? We need 5. 5Fe plus 2 plus 1 manganese plus 7 gives us 5 iron plus 3s plus 1 manganese plus 2. Tin is a plus 2. Oxygen's a negative 2. There's 3 of them, total negative 6. They have to add up to a negative 1, meaning iodine is going to be a plus 5. Tin is a plus 4 here. Iodine's a negative 1. Who's being oxidized? Tin is going from a plus 2 to a plus 4. So he is losing 2 electrons. Iodine is being reduced, plus 5 to a negative 1. Now, this can trip you up, because plus 5 to negative 1, you're going to want to say that's a change of 4. But if we drew a number line, negative 1, 0, 1, 2, 3, 4, 5, we have a change of 1, 2, 3, 4, 5, 6. So how would I put those two together? What's the least common multiple of 2 and 6? And the answer is 3. So 3 tin 2s plus an iodine gives us 3 tin 4s plus the negative 1 iodide. Now, these are more balancing, what we've been doing. I'm going to let you just kind of look at that. You can pause it, practice. I will print this off, and I will make a copy and load it tomorrow in class. So if you're watching tonight, you won't have answer key, but if you're watching over the weekend, you will. Hopefully, that helps.